Hello viewers, welcome to K Diagnostics, Dio here. Today we have a 2013 Mercedes Sprinter with a 3.0 liter. The customer complaint on this vehicle is the engine runs rough and the vehicle is losing power tremendously. So the first thing we're going to do is we're going to go in the vehicle and confirm the customer's complaint. We're going to start the engine and see if this engine is going to run roughly. And after that, we're going to connect the scan tool to the vehicle to see what kind of trouble codes we have in the engine computer. I want to mention that the owner told me that there are no lights on the dash. The check engine light is not on. So hopefully we have some trouble codes in the engine computer. But if we don't, then I'm going to tell you what directions we're going to go so we can figure out what's causing this engine to run poorly. So now let's go in the vehicle and confirm the complaint. So right there, as you can hear, the engine is running. I'm gonna rev it up a little bit. The engine is actually shaking. The whole car is shaking right now. I don't know if the camera is gonna be able to pick it up, but the vehicle is shaking. Now, one thing I have noticed is the check engine light is not on, and when you turn the key on, the check engine light is not illuminating. So let me turn off the engine so I can show you. I'm going to turn the key on. So the check engine light is supposed to illuminate over here, but it's not illuminating. Okay, so the bulb is most likely burnt. The check engine light bulb is burnt. So now let's start the engine. So the engine is shaking. This engine is definitely misfiring. I'm gonna take you with me under the hood so I can show you how this engine is misfiring. So this engine is misfiring very badly. Okay, look at this silencer. You see how this silencer is shaking? Yeah, this thing is misfiring really badly. You see that? Okay, so we have confirmed the customer's complaint. The engine is shaking. Now let's go back in the vehicle and scan the engine computer. This vehicle is misfiring, I'm pretty sure. So let's see what we got. I'm gonna turn the key on. I'm gonna get the scan tool connected to the vehicle. After I get the scan tool connected, I'll bring you guys back up. I got the scan tool connected to the vehicle. I'm gonna bring it up. I'm gonna be using my RTL scan tool in this video. So we have to manually select this vehicle. We're gonna focus on the engine computer, okay, because we are here to fix whatever that's causing the engine to shake and lose power. So we have 4 trouble codes in the engine computer. The first trouble code is P16C200, and it says combustion misfire cylinder 1 has been identified. So this engine is misfiring. Now we're gonna click on this arrow over here. We're gonna go into the engine computer. So let's read the codes once again. We have 4 trouble codes in the engine computer. Okay, we have 3 cylinders that are misfiring. We have cylinder 1, cylinder 4, and cylinder 5. So these 3 cylinder misfiring are causing the engine to shake and losing power. Okay, so this is a diesel engine. A misfire on a diesel engine is usually caused by a mechanical problem, which is going to cause low compression or a fuel delivery problem. Okay, we could have an injector that's not spraying the correct amount of fuel in the cylinder. That can cause a misfire too. Unlike a gas engine, which has to have spark, fuel, and compression, on a diesel engine you mostly need two things: compression and fuel delivery. Okay, so we know we're dealing with a diesel engine. What I'm gonna do now is I have to make sure that this engine doesn't have a mechanical problem. So we're gonna do that by doing a compression test. We're gonna do a relative compression test to rule out any mechanical issues that we might have. If we don't have any mechanical issues, then we are going to focus on the fuel delivery on these 3 cylinders. Okay, so now what I'm gonna do is I'm going to go to active test. I know some of these scan tools can allow us to do a relative compression test. So it looks like these are the only tests we can do. Let's go to adaptation units. Let's see. So there is no compression test we can do with this scan tool. Okay. Now, since there is no compression test we can do with the scan tool, what I'm gonna do is I still want to do the relative compression test to rule out any mechanical issues that we might have. So now I am going to remove the scan tool out of the way just for a second. I'm gonna go under the vehicle and connect a jumper wire to the starter signal wire. We're gonna connect a jumper wire to the starter signal wire so we can crank the engine. We're gonna crank the engine and we're gonna use a lab scope on the battery to monitor our voltage drop across the battery. Okay, that will give us a pretty good indication of how healthy this engine is. Okay, now we cannot crank the engine with the key, because if we crank the engine with the key, the engine is gonna start and that's gonna skew our test. Okay, so I'm going to turn the key off completely. I'm gonna remove the key. I'm gonna go under the vehicle so I can connect a jumper wire to the starter. Let's go to the starter and do that. We are here under the vehicle and here is our starter. I'm going to connect this alligator clamp to my starter control wire. So we're gonna connect to the wire that energizes the starter relay. So we're gonna use this jumper wire to energize the starter. Okay, so now let's go back in the vehicle. I removed the mat that protects the battery. So we're gonna use our snap-on lab scope to do a relative compression test across the battery. So what I'm gonna do is I'm gonna connect, so this yellow lead is gonna go to our lab scope on the tool. So I'm gonna connect this red alligator clamp to battery positive, and then the black one is gonna go to battery negative. And then I have a starter switch over here that I'm going to connect to the jumper wire. So this jumper wire comes from the starter control wire. Okay, so when I send power to this jumper wire, our starter is going to turn, which is going to crank the engine. Okay, we have to do that with the key off. So key is off. Okay, here is the key. We are basically just cranking the engine to see how much voltage drop we're gonna have across the battery. Okay, and this is how you do a relative compression test on a diesel engine if you don't have a scan tool that allows you to do a compression test. Okay, so now I'm going to connect my other side of my starter switch to this alligator clamp. Oops. So I got these two connected. Okay, so I'm gonna put these right over here. Okay, now if I press this switch, the engine should crank. So basically this switch is connected to, so one side of the switch is connected to battery positive. Okay, this wire over here, and then the other side of the switch is connected to the jumper wire that's coming from the starter. So if I crank this, I mean if I press this, the engine is going to crank. So listen, you hear that? So that's good. So now let's fire up our lab scope. So we're going to go to scope multimeter. Let's go to lab scope. We just need one channel, so we're gonna turn the other channel off. So the first channel is on, and as you can see, we are reading system voltage, okay? Because we have our lab scope test lead connected to the battery, okay? So now I'm going to drop my voltage down to 2 volts, and then I'm gonna AC couple this. We're gonna invert this, we're gonna filter it. I'm gonna increase my time base to 2 seconds per screen, okay? So now I'm going to press this switch so we can crank the engine, okay? So when we crank the engine, there will be some peaks and valleys over here across the screen, and those peaks and valleys should be even across the board if this engine has got good compression. All right, so now I'm gonna press this switch, so let's see what happens. So that's good enough. I'm going to pause this. We're gonna bring this back. So let's analyze the data. So here's what we got. So what you see over here is voltage drop across the battery. So what happens is when the starter spins, it draws more current to push a piston towards top dead center when that specific cylinder is in the compression stroke, okay? So when the starter draws more current, the voltage drops, okay? So the voltage drops to push that piston. I mean, it can be any piston. And at this point, we don't know which cylinders are these because we didn't synchronize our waveform. So the starter spins the crankshaft when the piston is going towards top dead center, and when the cylinder is in the compression stroke, the starter draws more current to push the mixture, I mean the compressed air in this case, towards top dead center, okay? It draws more current, which causes the voltage drop. Now, the rule here is having all these peaks and valleys identical to each other. And as you can see, they basically look similar to each other across the board. So this over here tells me that we don't have a compression issue with this engine, okay? So these peaks over here are all the same. If we had a mechanical problem in a specific cylinder, one of these humps or these peaks over here was going to be smaller or shorter than the other ones, okay? So this is how you can quickly do a relative compression test on a diesel engine if you have a scan tool that doesn't allow you to do a compression test. All right, for some reason my RTL wouldn't allow me to do a compression test on this 2013 Mercedes Sprinter. With this waveform over here, I can kind of rule out a mechanical problem. We most likely don't have a mechanical problem with this van. So now we're gonna focus on fuel delivery. Let's go under the hood so I can show you what we're gonna do to check the injectors, because we can have 3 injectors that are not spraying the correct amount of fuel in the cylinders, and that can cause a misfire. So now let's go under the hood. What we're gonna do is we're gonna remove the air filter box. We're gonna back probe the signal wire on the fuel pressure sensor on the fuel rail so we can monitor the fuel pressure on the fuel rails on the lab scope. With the engine running, we're gonna watch the fuel pressure on the rail, okay? And then we're gonna use an amp clamp around one of the injectors, whichever injector we're gonna get easily access to. We're gonna clamp an amp clamp around it. when there's current flow across that injector, our voltage should drop. So we should have a pressure drop when that injector opens, okay? And then we're gonna compare our pressure drop on the voltage waveform and the amperage on cylinder 1 and cylinder 2. Because remember, we had 3 cylinders that are misfiring. Cylinder 1, cylinder 5, and cylinder 4. The firing order of this engine is 1, 2, 3, and then 4, 5, 6. So cylinder 1, 2, 3 are over here on the passenger side, and the rest of them are on the driver's side. So the first cylinder over here on the passenger side is misfiring, the second one is not, and the third one is not. So this bank over here is pretty easy to access. I mean, the injectors on this bank. I'm going to use an amp clamp to clamp one of the wires on this first injector, which is injector 1. This injector over here is misfiring. We're gonna watch the waveform, I mean the current waveform and the voltage waveform of the fuel rail pressure sensor. We're gonna compare it to a non-good injector which is next to it. Okay, so if you have any questions, just hold on. I will explain this a little bit better as we do the test, and that will give us a good understanding of whether these injectors have a mechanical problem or not, because we could have injectors that are partially clogged. So I'm going to remove this engine cover. Okay, let's remove this guy first. Let's remove this inlet tube. This air inlet tube is gotta come out. All right, so back here is our fuel pressure sensor, okay? And the wire in the middle is our signal wire. So I'm gonna grab my back probing tool so we can back probe that wire. So we're gonna back probe the center wire, okay, which is our signal wire. So I'm back probing the signal wire of this fuel pressure sensor, okay? And then I'm going to connect my test lead to this back probing tool over here. So just like that. Okay, so this test lead is gonna go to the lab scope. Now I'm going to disconnect this injector over here, the first injector, okay, on bank 1. Okay, I'm gonna open up this harness so I can get my amp clamp wrapped around one of the wires on the injector electrical connector. I'm gonna do that off camera, and then I'll bring you guys back up once I get everything set up. I got my amp clamp wrapped around one of the wires that goes to the first injector, okay? And we have our signal wire back probed at the fuel pressure sensor. So we're good. So now we're gonna reconnect this air inlet tube because we're gonna have to start the engine to do this test. All right, so that's good. So now we're gonna reinstall our air filter box. All right, we got everything back on. The lab scope is set up. So now let's start the engine and see what we got. So as you can hear, the engine is running. So let's go back under the hood and see what we got. So this engine is shaking like crazy. So now let's look at our lab scope. Okay, so our green trace is the injector current waveform. Okay, so we have current flowing across the injector, which tells me that our injector wiring is good. And we can also see activity over here on the voltage waveform of the fuel pressure sensor on the fuel rail. So when the injector opens, you can see this drop over here. Okay, now I don't know if this is normal, because this injector over here is most likely not working, because this is cylinder 1 and this cylinder is misfiring. Okay, we know we don't have a mechanical problem. This injector is probably not spraying the correct amount of fuel in the cylinder. Okay, so this tells me that we don't have a wiring issue, because we have current flow across the injector. And if you look over here on this voltage waveform, okay, you see these little drops over here. Okay, so our pressure is dropping slightly. Okay, so now I'm gonna go and turn off the engine so we can do the same test on a non-good injector. Okay, so we're gonna move our amp clamp to cylinder 2. We know cylinder 2 is not misfiring, so we're gonna move it there and see what happens. Okay, so here's what we got. Actually, I'm going to pause this. Let me turn off the engine first. We're gonna save this so we can compare it to a non-good cylinder, okay, to a cylinder that's not misfiring. I turned off the engine. We're gonna save this waveform. We're gonna write fuel injector and fuel pressure sensor waveform, non-bad, misfiring cylinder 1, okay? So we're gonna save that. All right. So we're gonna unfreeze this. So now, what I'm gonna do now is I'm going to move my amp clamp from cylinder 1 to cylinder 2. So cylinder 2 is good. Okay, so I'm gonna move it to a non-good cylinder. I can either do it at cylinder 2 or cylinder 3, whichever one that's easier. Okay, it looks like it's gonna be easier if I did it at cylinder 3. Okay, clamping the amp clamp around one of the injector wires. So I'm gonna reconnect this. Let's do our last test. I'm leaning towards replacing these injectors. I wanna look at both waveforms of injector 1 and a non-good injector. So injector 1 is on a cylinder that's misfiring. I'm gonna clamp it around cylinder 3, which is not misfiring. Let's see if there will be a huge difference between the waveforms. But if there isn't a big difference, I'm gonna go ahead and replace the injectors. Okay, so our fuel pressure is good. Okay, the other thing I could check is fuel pressure, but the thing is, if we have a fuel pressure problem, it's gonna affect all the cylinders, not just cylinder 1, 4, and 5. Okay, so I'm gonna check the waveform of cylinder 3. We're gonna compare it to that one, and after that we're gonna make the call. Okay, I'm gonna clamp this amp clamp around one injector wire of cylinder 3, and then I'll bring you guys back up. So I got my amp clamp wrapped around one of the wires on the third injector, which is a non-good. So now I'm gonna start the engine so we can analyze the data. So let's go back to our lab scope and see what we got. Okay, so the engine is running. Okay. So here's what we have on the lab scope screen. There isn't a big difference, okay? As you can see, this waveform looks very similar to what we just saw on cylinder number 1, okay? Now, on our fuel pressure sensor signal over here, the drop is a little bit more pronounced, okay, when this injector opens, but I can't make a definitive call just based on this waveform over here, okay, because they look technically pretty similar, okay? So I'm gonna tell you what I'm gonna do, guys, okay? I'm going to turn off the engine. As you can see, the engine is shaking very badly, okay? So our waveforms look pretty similar. I'm gonna go back in the vehicle and turn off the engine. So I'm gonna go ahead and replace this injector, okay? Now let's look at our fuel pressure data PID. In case you have a question about fuel pressure, our fuel pressure is good. We don't have a fuel pressure problem. Right now, with the key on, engine off, we have about the rail pressure is 201 psi. So I'm gonna go in the vehicle and start the engine. We're gonna watch this rail pressure with the engine running. So this is gonna tell us how much fuel pressure we have in the rail. So now I'm gonna go in the vehicle and start the engine. Alright, so I got the engine started. So right now at idle, let's see what we got. So rail pressure, we have 4,200, okay, at idle. And if I increase the engine RPMs, this fuel pressure is going to increase. So fuel pressure is not our problem. Our problem is those 3 injectors are defective. So I'm going to go ahead and make the call. We're going to replace these injectors, and after we replace these injectors, this is going to be fixed, okay? So I'm going to go in the vehicle and turn off the engine. Okay, our fuel pressure is good. So 4,000 at idle is very good. That's good fuel pressure right there. So I knew fuel pressure wasn't our problem because I just wanted to show you if fuel pressure was our problem, it was gonna affect all the cylinders, okay? So I'm going to get my air filter box out of the way. We're gonna remove injector 1, 4, and 5. I'm gonna show you how to remove this injector over here. I'm gonna show you how to remove injector 1. It's basically the same process on all of them. I'm gonna do the one on the driver's side off camera, okay? I'm gonna get the air filter box out of the way, and then I'll bring you guys back up so we can remove this injector. I'm also gonna go ahead and call the dealer. I'm gonna call the Mercedes dealership so we can get new injectors from Mercedes, okay? So I'm gonna order new injectors, and then I'll bring you guys back up so we can replace this first injector. Alright, so I got the air filter box out of the way. So now we're gonna remove this injector. I'm gonna disconnect the electrical connector first. Again, it's the same process on all the injectors. Okay, now I'm gonna disconnect this return line. So we're gonna twist this little lock over here. We have to twist it. So basically what we need to do is we have to twist this lock, okay, counterclockwise, just like that. And then I'm gonna lift this line up, okay. So you twist this, so you twist it this way to unlock, and then you pull up. All right, so now I'm gonna disconnect the high pressure line. Now you gotta make sure you wear your safety glasses when you do this. So here comes our fuel line. So now we're gonna undo this injector retaining bolt over here, this torque bolt. We're gonna undo this one so we can remove the injector. So we got the bolt undone completely, so we're gonna remove it. Okay, so I'm gonna reinstall this fuel line back on the injector. So hopefully this injector is not really stuck. Okay, so we're gonna tighten this line just like that. Okay, and then we're gonna wiggle the injector back and forth. I'm gonna get some WD-40 and spray it around the injector. So right there, our injector is about to come out. So here comes our fuel injector. So this is how you remove a fuel injector without a puller, okay? So we got lucky, this injector wasn't stuck, so this one came out pretty easily. So we're gonna take this to the bench. I did receive the new fuel injectors. We're gonna write the new fuel injector ID on a piece of paper so we can put it in the engine computer when we're done, okay? Because these injectors have to be programmed after you replace them. So now let's take this injector to the bench.